catalysis. Under this, we are going to learn about characteristics of catalyst, types of catalyst, adsorption theory of catalysis. Especially under this, you have, as per CBSE board, shape selective catalysis and enzyme catalysis. We'll see one by one. First of all, catalysis, it is the process name, work name, phenomenon name. What type of phenomenon under this? Catalysis is the process of increasing the rate of chemical reaction by adding a substance, known as catalysis. The chemical reaction speed increases when you add a chemical substance. This adding process name only considered as catalysis. What is catalyst? A substance that does not involve in any chemical reaction or any chemical change, but it alters the rate of chemical reaction. Either maybe increases the rate of reaction, either maybe decreases the rate of reaction, either maybe optimize the rate of reaction. Such kind of chemical substance is known as catalyst. When you observe the before catalyst and after catalyst, when a chemical reaction, this is the graphical representation with respect to extent of reaction and potential energy. So without adding of chemical catalyst, this is the graphical representation. Here the reactants molecules are there in initial state. These reactant molecules collidal with each other, accident with each other. After that, few molecules get excited. These excited molecules are known as activated molecules. Activated molecules. These activated molecules only lead to the formation of product. These activated molecules combine with each other and form the product. Here the product, new substance is formed. This is product. These are the reactant molecules. So reactant molecules combine and accident with each other, collidal with each other to get energized. These energized molecules are known as activated molecules. Activated molecules combine with each other, you will get the product. So this is the process for before adding of catalyst. When you add the catalyst, this activated energy will be up to here itself only. Here the molecules and molecules combine with each other, you will get the product. It means before adding catalyst, this is the activation energy up to here to here, and after adding the catalyst, this is the activation energy. It means when you add the catalyst, the chemical reaction, reactant molecules activation energy decreases and speed will be increases. While moving from here to here, it will take some time. So here this is moving in the short way. It means the chemical reaction, the chemical substance which does not involve in the chemical reaction, but it increases the speed of reaction. In this way. What way the speed of reaction increases means it requires a less activation energy when you add catalyst. In the presence of catalyst, chemical reactions proceeds with the lower than the activation energy of the uncatalyzed chemical reaction. Characteristics of catalyst. Catalyst does not initiate the reaction, it merely accelerates the reaction. It will not start the chemical reaction. After starting of chemical reaction, it speeds up the chemical reaction. Small amount of catalyst is generally sufficient to speed up a chemical reaction. Catalyst remains unchanged in amount and chemical composition at the end of the reaction. It is not change either initial or final state. The chemical composition will not be changed. Catalyst does not alter the state of equilibrium but helps to attain the equilibrium quickly. A catalyst is said to lower the activation energy and thus increases the or rate of reaction. Sixth point, catalysts are highly specific. Here, in this specific case, when carbon monoxide reacts with hydrogen, you are getting methane gas and water. But when I change the catalyst, instead of nickel, copper, when I changed, the same carbon monoxide gas reacts with hydrogen to form a formaldehyde. So these are all the catalysts are specific. And catalyst is also used as a promoters. It means speed up the chemical reaction fastly, and as well as catalytic poisons. Promoters are substances that enhance the activity of catalyst, while the substances that decreases the activity of catalysts are catalytic poisons. Example, in Haber's process, nitrogen reacts with hydrogen to form ammonia. To get the ammonia, I required one catalyst and one promoter. The catalyst is iron, promoter is molybdenum. Instead of catalyst and promoter, when you use H2S, the entire chemical reaction should be spoiled. You will not get the ammonia gas. Hence, this H2S is a catalytic poison. Second example, formation of sulfur trioxide from sulfur dioxide and oxygen. Here also you required one catalyst, that is platinum. No need of promoter in this case, and when you want to spoil this chemical reaction, you required catalytic poison is As2O3, arsenic trioxide. So these are the important characteristic properties of catalyst. We have to use small quantity. All the catalysts are specific, highly specific, and also catalysts used as a promoters and catalytic poisons. This catalyst chemical substance will not change the chemical composition, or it will not involve in the chemical reaction. Either it increases the rate of reaction or decreases the rate of reaction or moderate the rate of reaction. Next topic, adsorption theory of heterogeneous catalysis. These catalysts in what way utilized in adsorption theory? Our topic is surface chemistry. Surface chemistry means entire the chemical reaction. What we have studied here in this case means the adsorption process only. So catalysts in what way utilized in adsorption process? Let us see. The modern adsorption theory is the combination of intermediate compound formation theory and old adsorption theory. The mechanism involves 5 steps. Either modern concept or old concept. In what way the adsorption theory is going on, we'll see. First step, 5-step mechanism. First step, diffusion of reactants to the surface of the catalyst. Adsorption of reactant molecules on the surface of the catalyst. Occurrence of the chemical reaction on the catalyst surface throughout the formation of an intermediate. A desorption of reactant molecules to form the products from the catalyst surface, and thereby the making the surface available again the more reaction to occur. Diffusion of reaction products away from the catalyst surface. So here 5 steps I have given, very simply I am going to explain you. So these are two are the reactants. This is A and this is B. These two want to react to form a product like this. This is the A and again B combinedly. This product want to form. So simply these two will not react with each other, while you have to add a catalyst. You have to add a catalyst. When you add the catalyst, then only the A is react this one is reacts with B and form this product. So in this way you have to follow 3 steps. One is diffusion. Diffusion of reactant. Reactant molecules must diffuses. So here which is the reactant, which is the catalyst, I am going to explain in this slide. So mechanism. Observe here. Step 1. What is that? Diffusion. diffusion of reactant molecules. So reactant molecules are these A and B. These want to react with each other. First, these molecules are diffusers. Diffusion means moving towards catalyst. There is a speciality of catalyst. Catalyst attracts these two reactants. These two are not reacting with each other. That's the reason this attracts with two reactant molecules. That is called a diffusion. First diffusion. Okay. Second step is adsorption. These are moving. Moving process is known as diffusion. After diffusion, this catalyst should be adsorbed. This A is adsorbed. Adsorbed. B also adsorbed on the catalyst. So A and B adsorbed. This adsorbed process only considered as adsorption. First one is diffusion, and in second step, catalyst adsorbs the reactant molecules. This phenomenon is known as adsorption. And third one, formation of an intermediate. Third step, formation of intermediate. See here, intermediate is forming. How? What way? When you observe here, A and B, there is no bond between these two. Actually, our target is A plus B, you will get a bond B. This one, this product, I want to get it. But individually, without catalyst, these two reactants are not react with each other and form product. So, because this direct reaction is not going on, hence we are utilizing a catalyst. This catalyst first adsorbs the two reactants diffuses and attract here. Third step, reaction intermediate formation. This A and B now bond is formed between these two because this catalyst holds A and B closely together. Hence, at that particular state, the bond is formed between A and B. This is reaction intermediate. Along with the product and catalyst, this cluster form, this form is known as intermediate compound. So, intermediate compound. After that, desorption. Desorption means what? Removal of adsorbate. Here the adsorbate is what? A and B is the adsorbate. The process of removal of adsorbate is known as adsorption. So now here what happened? Desorption will happen. That is the fourth step, desorption. Then this will be, bond will be come out. This A and B both will come out. And as it is our catalyst without changing of any composition, it forms as it is. Initial in what way it is, and final way also the same situation. And desorption after, what will happen? Products away from the catalyst. It will move from away from the catalyst. This product is moving outside. This is moving some away. So that in this way, the adsorption process, the catalyst involving in adsorption process. So this is the mechanism of catalyst. Catalyst is involving in adsorption process. So the mechanism involves 5 steps. First one is diffusion. These molecules diffuses towards catalyst. Second one is adsorption. Third one, intermediate formation. And the fourth stage, these AB product is undergoes desorption, and both two catalyst and product away from each other. So this is about the mechanism involved in catalyst and adsorption. Merits. This theory explains why the catalyst remains unchanged in mass and chemical composition at the end of the reaction and is effective even in small quantity. So already we experienced it. Catalyst is not involved in chemical reaction. It is not changed in chemical composition at the end of the reaction, and it is effective even in small quantity. A little quantity when you add, also the chemical reaction speed will be increases. That is the speciality of catalyst. What is the demerit of catalyst? This theory does not explain the action of catalytic promoters and catalytic poisons. In what way the promoters are acting to speed up the chemical reaction? In what way the catalytic poison is acting, that mechanism they didn't explain. So this is about the demerit of catalyst, and this is about the merit of the catalyst used in the chemical reaction. Next topic is types of catalysis. Types of catalysis. Catalytic reactions can be broadly divided into two following steps. One is homogeneous catalysis and another one is heterogeneous catalysis. Homogeneous catalysis means the reactants and the products and the catalyst all are in the same phase. See here, reactants and the catalyst are in the same phase. For example, same phase means H2 plus N2. Both are gases. This is the gas, hydrogen gas, and this is nitrogen gas. Here I am using one catalyst. For example, iron is used as a catalyst. So these are the gaseous state, but this is what state, ma? Solid state. So solid state and gaseous state, two different states are there. Such kind of catalysis is known as heterogeneous catalysis. Heterogeneous catalysis. If both are existing in same phase, that is homogeneous catalysis. I am showing you few examples for homogeneous catalysis. So sulfur trioxide and oxygen both are in gaseous state. Nitrogen oxide is used as a catalyst to get the sulfur trioxide. So here nitrogen oxide and reactants both are existing in the same phase. That's the reason homogeneous catalysis. Second one, hydrolysis of ester. Ester CH3COOH, this is the ester. This ester hydrolysis, when placed in water in presence of hydrochloric acid, these are in the liquid state, both are all are in existing liquid state. Ester is liquid, water is liquid, hydrochloric acid is liquid. So reactants and the catalyst both are existing in the same phase, hence it is called as homogeneous catalysis. One more example, sucrose solution C12H22O11 plus water in presence of sulfuric acid, it forms glucose solution and fructose solution. So what is the meaning of homogeneous catalysis? Reactants and the catalyst are in the same phase or same state. Such kind of catalysis reactions are homogeneous catalysis reactions. Heterogeneous catalysis. Reactants and the products, reactants and the catalyst both are existing in different phases. Example, in contact process, here sulfur trioxide and oxygen both are gases, but platinum is solid. Both existing in different phases. This type of catalysis reaction comes under heterogeneous catalysis. Example, Haber's process. Scientist Haber prepared ammonia. That is the reason this is called as Haber's process. Haber's process for ammonia preparation, nitrogen and hydrogen both are existing in gaseous state, but iron is existing in the solid state, two different states. In Ostwald's process, nitric acid we can prepare, where ammonia and oxygen both are existing in the gaseous state, but platinum is solid state. When the reactants and a catalyst both exist in two different states, such kind of catalysis reactions are known as heterogeneous catalysis reactions. Another classification, types of catalysts. Third one, first one is homogeneous, second one catalysis is heterogeneous catalysis, and third one positive catalysis. The catalyst increases the rate of reaction. Such kind of catalysis reactions all are comes under positive catalysis. CO plus 3H2, the speed will be increased where nickel is used as a catalyst. Negative catalysis. Catalysis decreases the rate of reaction. The speed of the reaction should be decreased when you add alcohol here for this reaction. So this is example for negative catalysis. Autocatalysis. Without adding of any catalyst, the reactant molecules only act as a catalyst. Such kind of chemical reactions all are comes under autocatalysis. Here manganese ion or potassium permanganate KMnO4 or Mn plus 2 act as an autocatalysis. So MnO4 minus plus oxalic acid H2C2O for ionic equation I have written here, plus 16H plus you are getting Mn plus 2 plus 10CO2 plus 8H2O. So this reaction indicates autocatalysis. Induced catalysis. Induced catalysis means one reaction influences the rate of other reaction which does not occur under ordinary conditions. So after completion of one chemical reaction, that chemical reaction again undergoes, it is a continuous reaction. For example, here Na2ASO3 aqueous when reacts first oxygen to, there is no reaction, no oxidation. But the same reactant when reacts with oxygen plus Na2SO3, when you add, you will get a Na2ASO4 plus Na2SO4. So it means due to the Na2ASO3 and Na2SO3, this is induced this one. Because of adding Na2SO3, this Na2ASO4 is involving in the chemical reaction. Such kind of chemical reactions are induced catalysis reactions. Seventh one, shape selective catalysis. Shape selective catalysis, example is zeolites. Catalytic reactions that depends upon the pore structures of the catalyst and the size of the reactant and the product molecules. Shape selective catalysis means catalytic reaction that depends upon the pore structure of the catalyst and the size. Example, zeolites are the good shape selective catalysts because of their honeycomb-like structure. ZSM5 used in petroleum industry. So based upon the structure, they are involving in catalysis reaction. Example, ZSMS5 alcohols is going to change into gasoline in petrol. Enzyme catalysis. In few cases, enzymes also act as a catalyst, so that these enzymes are known as biochemical catalysts. Example, urease. When NH2CO NH2 reacts with water, you are getting ammonia gas in presence of urease enzyme. So these are all different types of catalysis reactions. As per CBSE board, we have enzyme